In this project, GHD, working with the CRCSI through their spatial analytics project, their rapid spatial analytics project, was trying to understand the way in which data is changing the nature of infrastructure as we know and understand it. We tend to form the view that with data rising exponentially through the Internet of Things, which we all know and understand, it's going to change fundamentally the nature of the infrastructure around us. If we can capture 10,000 more data points in a site where we usually only capture 10 or 20 data points, that helps us understand the nature of the challenges at the site, but it also influences our ability to process that data and convert it into usable insights.
In this project, we're trying to turn the promise that Matt spoke about into a demonstration project that people can actually touch and feel. So we're working with the telco providers to create this huge amount of data, and we're going to use cloud-based analytics to create spatial information that will show how you can go from just counting things or understanding what happened last week to how you can change the way you actually manage that asset now in real time, using an understanding of what people are doing, where they're going, where they've come from, and how long they're spending in different parts of your asset. So that could translate into decisions about safety, especially with overcrowding on Melbourne's public transport network. It could translate into retail decisions, signage and advertising, or it could translate into new decisions about how an asset is managed.
So what we're seeing in this project is, for the last 30 years, telco carriers have been able to produce an enormous amount of data, and that data has just increased. In the last 10 years, providers like Google have said, how can I mine that data for insights? Google Maps with their yellow, green and red traffic density data, it's just data mining, for instance, cell phone towers around you. So instead of spending $1 billion building your carrier network, you can spend a couple of $1 million like Google did and data mine that network available. What we're seeing through this project is for thousands of dollars, not millions of dollars, we can recreate exactly that same data set, and we're doing it at a complex piece of.
In our project, we're getting the data at a critical piece of infrastructure and using it within that asset. So the scale is different. We're trying to understand the way people are moving inside an asset and how we might be able to demonstrate some value in understanding that in real time. The asset operator that we're working with has got historical data, but we're trying to demonstrate that investing in real-time data within the asset can actually change the way they manage that asset. And this project is about demonstrating that the spatial aspect of that, where people are, how they move around the asset, how that adds a new type of value in addition to the standard counting information that they get.
So let's take, for instance, a transport asset. We've got a range of different types of people. You've got your metropolitan users, you've got regional users sometimes, you have people commuting from interstate in these transport hubs, you've got people in CBD locations that just use those transport hubs and just dwell there, you've got in some cases retail. Take that complex smart city pretty much in and of itself and ask yourself what some of those challenges are that this technology can help us understand. Use the safety context. If we know that people are exiting the site, not using the exit and are doing it in an unsafe manner, we can use that to inform the design of the pedestrian accesses to the site, this transport site, let's say, as an example. If we know that people are dwelling for a long period of time and there's been a rapid build-up of those people, we can use that trigger to issue security down to that site just to disperse the crowd or to make sure that everyone's safe and well. Conventionally, you haven't been able to do this with technologies that are available. You have laser counters at the door, beacons require people to log on to their phones and do things. You have algorithms running on CCTV cameras, which are enormously expensive to try and give some insight to this real-time data. Go back to our earlier promise. We're taking the same level of data that carriers have, which Google then proceeded to develop. Now that same data set is available for individual infrastructure owners, and we're helping converting it into operational insights.
The outcome of this project, hopefully, will be a series of algorithms that will enable us to process this information in real time and present it to the client to enable them to make decisions in real time. So that will be one key outcome. The other key outcome will be the demonstration itself. Understanding from our community and from the technical community that this can be done is very different to demonstrating how it does add value to the asset, and hopefully we'll come up with some good arguments so that this can be expanded into other assets, but also into other operational decisions within the asset that our case study is working with.